How's it going, everyone? Welcome. Eulier Gonzalez. That's right, you hear it. So, in this video, let's take a look at why do we even need to have closure? Why do we have closures? As a way to recap of how do we get here. And so far, in this series of videos, taking notes out of this JavaScript, as well as the ecosystem that is around JavaScript, which a lot of people actually they don't know even the name of the legal trademarks owner or the technical people that is involved in the spec of improving and putting champions to the language or how this process work. So most of them they don't have idea of that, and I don't blame them. Okay. In my case, that doesn't work. In my case, what works is that I understand how do I get here, and where is all of this, right? This is one of the reasons why I actually take notes and explore, thanks to Kyle Simpson's systematic way to describe a story, in this case, the JavaScript, at least the three main aspects of the language. So first is not only the type system, but the scope and closure, as well as the objects, right? So this is for the technical aspect, which once you learn that, it is straightforward. But the other is what is the social aspect around this, right? And as I mentioned before, is the legal trademark. Who owns the legal trademark? What is the people that oversee the spec, the TC39? What is the goal of this group? They don't want to break the web, and how they do that. Oh, let me recharge here. Okay. Oh, there you got it. Oh. Okay. Hmm. All right. Awesome. Good. So now is, and also is the motto of the TC39, which is, hey, we don't want to break the web, and how they do that by gathering in a room every a monthly after every month after it. So this is made of, or this commit is made of several peers on the web industry or browser vendors that they propose now a champion to that needs to wake up to the top in all of these different phases from 0 to 4, and if it goes well and pass through all of these phases, now it becomes part of the language, right? But I don't want to go into this detail around the JavaScript and the social aspect of JavaScript, just to briefly mention, because what is relevant in today's video is to understand why do we have a scope. So as a way to make this recap quickly about who makes the JavaScript, who owns the legal trademark, or and now who oversees the technical aspect? The TC39 group. What is doing that group? What is the motto? Which is don't break the web. How they do that? By promoting or proposing several champions that need to wake up all of these different phases until it is approved. And because browsers vendors, which is the main place where this language is executed, this JavaScript engine will live, they're going to implement those specs at their own pace. The spec says what to do, know how to do that. Another crucial, important aspect here. And as we explore is how now the browsers guarantee this backward compatibility. We look at polyfills, and the JavaScript in itself allows to write code in different approach to solve problems. So whether it's a functional programming, when computation is needed, okay, so you need to describe computations, and following is a lambda calculus. Again, something that go beyond the scope of today's video, but this functional approach is useful when you need to describe is computations. But it turns out that the real world doesn't work. It behaves by interacting with other stuff. Okay, so this is what we have object-oriented programming, where you need to actually share functionality or data among other objects. Okay, and then there are several patterns around that. And the other is the procedure. Now, on that, and as we move on to understand is the concerns about JavaScript, specifically how it works, how these machines work when you disassemble this machine, how all of these different pieces works together. And this is getting into the engine of JavaScript, or particularly of how JavaScript behave. That is, if this work as a compiler or as an interpreter. And despite that this has been created as an interpreted language, it behaves more like a compiler language. Not it is in its distribution, how the code is distributed, but how the code is analyzed, which is one of the reasons why in the previous video I saw is that scope and understanding how to work with variables and the different scope that we can have in the language, as well as certain statements, hostable statement that allow us to define that. That is, for example, functions var, arrow functions var, generators, async functions, and async generators. And it turns out that this statements, all right, which hosted, and what the concept of host mean, and then explore is the other different scope, whether it's a global scope and where this global scope live in different environments and or co-organizations. And speaking of which, how it is useful for us to use this now, the principle of least exposure, aka is to limiting the overexposure of variable per scope, right? Because we can eliminate a series of class bug. So not only is the name collisions, but also the unintended dependency or the unexpected behaviors. And then now move to what closure is and where closures are, where and why do we have closure, which is here, right? So the TLDR of this is to understand first, which is something that Kyle Simpson actually described in the Get Started JavaScript, okay, is who makes this language, the legal trademark, who owns the legal trademark, who oversees the technical aspect, which is the TC39 group, what is the goal of this group, and how now they guarantee that they don't want to break the web by having this particular process from 0 to 4 stage that actually a champion needs to way up to the top. That becomes available to the spec. The spec says what to do, know how to do, and it is up to the browser, which is the main language that, or the main environment that this language is executed, that is up to those browsers to define when it is going to be implemented, right? So there are several browsers out there, Google, Firefox, Safari, in Microsoft, right? Each one of them has their own particular JavaScript engine to process that. And it is up to those browser vendors to decide when to do that. And also to understand now, as I mentioned before, is the different way of writing programs here. Functional, object-oriented programming, and procedure, and when you can use each one of them. So a concern around the JavaScript, if this is a language, how this behave, right? It is behave like a compiler language because the way how it analyzes the code, not it is distribution. And you can take a look at that observable behavior, which is something that we're going to explain that in today's video, but also is to understand the concern around this scripting language, whether it's Python or JavaScript or any scripting language that goes line by line in executing your code. But it turns out that JavaScript back in 2011, so there were a group of Mozilla engineers that they proved that the language is fast enough by pouring an Unreal game engine into porting an Unreal game engine into the browser. There is also just wants to hit the brake here to show you something, right? Which is speaking of this, that JavaScript in itself is a powerful, fast language, and the concerns around that with the ASM, which is a subset of the language that allow us, the Mozilla engineers back then, to talk or to send directives specifically to run some optimizations to the JavaScript engines. And then we have now this spiritual successor called WebAssembly that the developers in 2016, 2015 and 16, and Mozilla, they want to take things a little bit further. So by skipping the parsing phase, the phase when the source of text is now converted into, so the string of text is now converted into meaningful tokens into the language that create this abstract syntax tree. Okay, so we want to get rid of this phase, have a language that is like an intermediary low-level language, like an assembly language, and then now run the code in this particular environment. In all of this is known as the WASP, the web assembly. Okay, let me see. Oh, I do think it's called Messenger, right? Messenger.beto.co. Messenger.beto.co. Right? Is now a game here. As you can see, is using. If we inspect the technology that it's using, it's using Svelte and 3.js. It is holding all of its data in Firebase. And if we inspect the code here, oh, it doesn't allow me to inspect the code? That's interesting. Okay, there you got it. So abeto.go. Right, somebody use now that we craft interactive real-time experience. And as you can see, this is something that is powerful here, right? It's mounting the application there, and as well as a WebLG here, right? So this WebLG is now loading this application here. You have some of these HTML tags that live here, right? And some of the style here. And of course is some JavaScript code that it seems to be loaded here. So it's using now the canvas here to actually render this, and that is using it the data engine, the 3GS, to load that. And we saw this was pretty fast to do so, right? It doesn't take too much to actually do so. And if you begin the game here, so all of these instructions that must live is in some sort of source. Oh, look at this, right? It's using its WASP to do so. React developer tools, that's of course what they're doing. They must rely is on that. And now it is quite interesting because it's also using some of these web workers as well. Right? As well as the Webpack. It's using Webpack to compile all of this, and the WASP. And you can see this is a huge file here that we might assuming that is the one who is probably setting this instruction here. Okay. In all of the sequence and so on and so forth. You can also move the character here as you like to. Alright. Perhaps it's not that quite easy to go with, but you can understand. The thing here is that this particular game, alright, which is multiplayer, there is a lot of logic and concern about it, but as you can see, the game moves smoothly. When I try to run that on my older device, so for example, in Samsung's devices, well, you kind of have that intuition. You can talk to them or do a click in here, right? And how it's actually changing. So this is the concern around those developers, right? So the thing here is that now we have saw the power that JavaScript is indeed a powerful language. It is using now WebAssembly as a way to run this code. And I mention all of this because this is part of the social aspect and the social theme that is around of JavaScript, as well as the use script, which is telling now, is a directive that indicates to the language, hey, this particular programs we're gonna change its behaviors, so now the developers can have a better chance for optimizing and running the JavaScript code. And then also look now at the more technical aspect that I don't want to dive deep into that. I won't delve too much into that, which is what a program is, what a JavaScript program means, how you can cooperate different programs, how you can make one or different programs to cooperate among them, and also is what a value is, different type of values, whether it's primitive or objects. What is now an object? What are the different type of object we can have? So whether it's a hash map or an array or a function as a value, right? How can we define as a function? What are the different ways to define a function? Function expression and functions definitions, and also what is function so powerful, the concept, because it allows to held a set of instructions and hold them as a value here. So also is how those values works, what are the kind of operation that we can do to this value, how we can convert one value to another value known as type conversion, and how can we compare is to values, all right, of different type, and what is the equality means in JavaScript, at least for objects and for primitive, and also is how can we organize our code here that allows to make it that it makes our code much more easy to organize, maintain, and also provide new features or fix some bugs that might happen. So this is the functions, the classes, and the EX6 models, and also some other these low-level features that are part of the language. So for example, how do you iterate through an element? What is the iterator protocol? What is the iterable objects? What are the properties of the functions? The anatomy of them, like the closure, as well as the value of this, and also the anatomy of the objects, which is the prototype inheritance. or the prototype object-oriented programming. So all this is just to briefly mention is the things that we need to know in JavaScript as a way to understand is how do we get here. And as we delve now into the scope, which is another, and this is part of the anatomy of JavaScript, technically speaking. So we went through understand that why working with variables is one of the most important things that you do in your programs, and because here the scope and its relationship is where you can put those variables, whether it is block and function. This the scope is determined is before the code is executed, and since functions and blocks are a scope, and in our case functions is in a scope, that is that where you can put now variables inside of that, and since functions can be held as a value in our programs as a variable, right? And this scope structure doesn't change by runtime conditions unless you explicitly do that, which is using the eval to change now, or the function to change now the runtime conditions. But if you're not, then it will stay and remains the same. So to understand now, for example, is why JavaScript actually behaves as a compiler language is when you look at three particularly the observable realities of these three topics. First is what happened when JavaScript analyzed errors, so syntax errors, how it behaves, and also is when it comes to detect early errors, and the other is the hoisting. Okay, so when you observe now in each one of those scenarios how JavaScript behaves, you can start to see is, hey, yeah, you can start to see is that JavaScript behaves now like a compiler language rather than an interpreter one. How so? Well, because when you now throw an error, when you do a syntax error, it actually is detecting that error before the code it is executed. The similar for the early errors, and the other is for the hoisting. So because in traditional classic compiler theory, this has three phases. You have now the tokenizer and the lexing, which converts each one of those strings, or each one of those characters here, into meaningful tokens to the language. And the difference between a lexer and the token is that lexer or the tokenizer is going to consider that the next token is part of a meaningful syntax into the language or not, right? So for example, with var or functions and all of this kind of stuff. So once now the engine process that and have all of these different strings of meaningful tokens, right? So a good example is when you read this kind of sentence, right? And when you read each one of those letters and then you compose that per meaningful tokens for you when we call on submit with as you and so on and so forth. Okay, so once now the engine has is all of this meaningful token, this lexing process. Okay, now it is time to see what is the relationship among each one of them. I am not sure if there is educative.org, what you say is the how to build a compiler. Not sure if this is it. How to build a compiler. Or building a compiler. Or even compiler design. Code generation and optimizations. Compiler design. But I do want is to instead of all of the theory, is more like a, let me see if I can get that, build a compiler. I know there was a website that allows you to build your own Redis. Okay, CodeCraft, that's right. CodeCraft actually have that. Let me see if you can now build your own interpreter. Oh, that's it is, or compiler, right? Build your own compiler. Okay. From CodeCraft. You know, CodeCraft. No, but they say it's build an interpreter from scratch. Yeah, they only have that. Build an interpreter from scratch. Okay. Yeah, build an interpreter from scratch. Yeah, build an interpreter from scratch. Yeah, it's this one. This is the challenge here. Parentheses, breaks, or the single tokens, lexical errors. You know, this is a very something. This is something that is not trivial. It's not a trivial task. Scanning literal numbers, literals, identifiers. So all of this is just to make sense of why do we even care about closures, and we can dive deep into this topic, and also how you determine its scope in this interpreter, A of else statements, and so on and so forth. But in our case is just resolving and binding, identify resolutions, you know. And I do think this is quite compelling, quite interesting, in order to understand now how a JavaScript or any scripted language or an interpreter actually works behind the scenes. So, and how now JavaScript is, how JavaScript differ from doing so. So this is why when we look at what the lexical scope means, is where it was written. In this lexical scope, we'll look at now an illustration around it. This illustration is based on some real life examples here. So for example, is that how now the lexical scope works. What is the lexical scope? And what happens when you have variables with the same name, a different nested scope known as shadowing, okay? And the different scope that we can have, whether it's a function or a block, how these variables will behave in each one of those contexts, and also how these variables, whether it's a var, let, function, or const, will behave when iterating loops. Particularly the the classic for loop, all right? And because of that, okay, we now look at the other implied scope, that is the parameter scope, which is something that you shouldn't mess with it, but it's important that at least that works. So function scope, so functions, parameter scope, arrow functions, and block. And how useful is for us to define is or use functions named rather than arrow functions. Each one of them create their own scope, but the benefit is that we can now hold that reference, hold that identifiers at lexically, and use the name as descriptor of what this function does. So, and we also look at the different or the other scope that are in our language. So, for example, is the global scope, and where the global scope live. Why do we even have a global scope? What is the main reason of the global scope, which act as a place to cooperate across different part or variables in our programs. So we look at the browser, how the browser behave when you define certain identifiers, var and functions, all right? And also is the and also is the, how do you put it? The global variables that we can have access, like the window object in the browser, how this window object behaves, shadowing, global window shadowing also occurs. For example, another environment is the service worker, how the self actually works, and how the self, which is the global objects, and it's behave pretty much like the var, like the global object from the browser. Also the ES6 models, which it doesn't have any global objects, but when you inspect now how you can have access to the global object, it does that via the outer environment, aka the model scope internally has a reference to the outer scope, making you available to access to the global, but not to define variables and functions by default. All right, you can do that explicitly. So the other is the node, right? And how know whether it's with CommonJS or ES6, each one of them is a way to organize the code. And speaking of which, and because overexposure of variables is one of the problems here when working with scope, because it leads to several problems. So name collisions, unintended dependency, and unexpected behaviors. But more importantly is the name collision. Well, by limiting the exposure of variable per scope, we can save ourselves to do so, whether it's by using its var, let, and cons, right? So another is that as we delve into that, the another is as we delve into this that word. Oh, okay. As we delve and search deeply and laboriously. Okay, that's interesting. So as we delve into the the reason of why we must limit the scope, the overexposure of variables in a scope, okay, whether it's by using var or let and cons, and when to use that. It is also that when you use now functions, it is not useful to define that inside of a block, right? Especially because it is hard to detect those errors, right? So functioning block is something that is not desired, and if you need to, it is preferred to go with a function expression that holds that, and then check in that particular scope what you need. Why we're talking about this? Because this is something that is used a lot in the scope, in providing polyfills, okay. In other words, it's providing the code necessary for all the browsers to run future JavaScript, future JavaScript. Okay, so all of this is just to a quick recap of how do we get here, right? Yeah, that huge, that massive recap of 41 minutes. So now that we look at another aspect of the functions, is the closure. This is something that is exclusively, so now that we know the ins and outs of lexical scope, it is also important to understand another topic which is part of the anatomy of the function, and that is the closures. So when you find yourself in the need to use a variable over time in a function scope and then execute that in a different scope from where the function was defined or instance or access through, a closure is created. So aka a closure is from the observable behavior. A closure is created when you define a function that hold a reference from the outer scope. You return that function's reference to be called in a different scope, and then that function is called in a different scope. So there are three cases here. Okay? There are three cases. First is define the functions that holds reference to the variables from the outside scope, and this outside scope can be is the global scope or the function. So for example, it can be something like this, right? So the global scope you hold now here is greeting, for example, right? You say hello. It can be from the outer scope, and here you define is another here to say hey, or something like this, right? You then assign here, say hello, and here you say hey, I'm gonna define as a function that is print or call salute, okay, that this function will have a reference to the outer variables, for example greeting in our case, and then I want to return that. So then in a different scope where it was defined, you may want to have access to, or in this case we can call this hello, and some sort of counter here, Okay. So if you define, for example, this and say, hey, I want you to return me is this, okay, so number times saying hello is equal to this. All right. And then if you want to now execute that salute, in this case here, right? The question is that you wouldn't be able to execute salute here. Oh, you did. Okay. Okay. Yeah, because it entered into the scope, right? And now salute not only. This is one of the reasons why we shouldn't use this function in block scope. Okay. Yeah, this is one of the reasons why we shouldn't use this. You say salute again. It is calling that, right? So now you're referring is counter here. And there you got it, right? So salute, and as you can see, so here, so not only that we are creating is a closure over a variable that was defined as it is here in a different scope, we are holding it as reference because let won't exist in this another scope. So if you're trying to have access to the counter here, it will throw you a reference error because counter doesn't live there, right? But the thing here, and you may wonder, is like, why do I actually pull this stuff here? It's just to show you that these identifiers that now live in a different scope, and the same for this here. So those variables that are closing over of that function, okay, they create now a closure. So the observable reality here, the observable behavior is that it needs to be defined as a function, and inside of the function have reference to the outer and if these functions hold reference to the outer scope, right? This variable hold reference to the outer scope, and then that function is executed in a different scope from the variables. So now a closure is created, right? So the thing here is, because this salute is still now calling that, right? So somehow now this variable is now being remembered, right? But what is remembered is the reference, not the value in itself, okay? And how can we make sure that that is the case? In other words, once we know this, how can we actually make sure that we don't run into some issues by running this or by letting this live link to these variables? How can we, for some reason, at some point in our code, we can get rid of that? Okay, so the way to do that is by removing is any reference to the function. So in our case here, try to remove the reference of salute identifier by saying it's salute here, and then assign to a new variable to say, hey, reset. So when you try to call salute, right, this identifier that previously have a function, but now you reassign that with a different value, all of the reference of that function now are candidate for the garbage collector. So the thing here is that we need is that reference to release that from memory. So a more useful way to do so is by holding is now a reference to that. And by holding a reference, you can say is as a function here to say, hey, let me is use that as it is, right? So now by holding a reference to greeting, okay, we might overriding greeting here. Yeah, indeed, we are overriding its greeting here. We can say is now something like this and say just for the sake of the example, we can say is time saying hello, hello, right? And by the time that we call is a greeting here, that identifiers now hold a reference to our functions and is creating is a close over the counter variables. So how can we now here is to, well, remove that from memory or make that a candidate for the garbage collector to release that. This algorithm that will handle that memory management for us. So, well, we got now the greeting, and we can is replace that with a different value as it is, right? You say reset. Now, I am mentioning this because as you can see here, you can create this a closure not only by wrapping into a function, but also is by not only by you create a closure is for variables that live by referencing variable from the outer scope. So for example, like this. Okay. So variables that live in the outer scope as it is, and you held that inside of the variable and you held that inside of the function and execute that code in a different scope from when the variable are from, now you are effectively creating is a closure. So traditionally we look this scope is as a function, but it can be also a block. It can be also a try and catch as well. Here you can say, hey, try, so go, and then the catch here, right? And you have now E, okay? And here you are now is doing so, okay? So you try this, and here is some code that you might have, right? But in our case, let's go to now, as you and let me do this here. Let me say console log of greeting here. So if you do this, it say, hey, greeting is not a function at this moment in time, right? So this moment in time, it say, hey, no, greeting is not a function. But if you for some reason now throw an error here and you get access to this, say, hey, new error, oops, right? I need to is throw an error, my bad. Need to throw a new error, right? Now you can have access to that reference. And not only that, if you call greeting again, look at this. Is holding is the outer reference of counter. And just mention is just to show that not as a fun stuff to do that, the clever tricks to show off, right? I'm flexing here. No. It's just to understand that there are scope, and this is according to the ECMA script. So functions block and catch actually create a closure, actually creates in a scope when you define this, and it's inside of this that you can create now again a closure. So understanding these sort of nuances is something that can help you to avoid not only errors but also to spot on some potential problems here. Now, as I mentioned before, every time that we need to get rid of those closures, and another question remains here is to, hey, those closures now are by variable or by scope, right? And it turns out that when I look at a particular exercise here, when I holding is now a reference of another reference, computations in this case, right? We are creating is now a closure around this reference that is holding these computations. But it turns out that now this reference here will live in the memory here when this function is executed. But when you pass is a huge, long collection of that. So to be sure about when you having is a nested reference of closures, right? So when you are deriving that state, you also want is to clear up that afterward, okay? So for example, if we do that here, if we receive now an identifier, we say function, so manage student here, so manage student grades here to say, hey, this is the student, this is the student record, right? And here you have is, well, var grades, right? That'll be now the student records dot map, and we just only want is to call get grades. Okay, great. This will be now is a return a function called add grade. Okay, so you're gonna have is this, right? Let's actually copy this. Actually copy all of this, right? So when you now pass a new grade here, all right, and if we want to inspect is what the students are inside of this function when it is evaluating students, okay, student record, this must be a plural, like this, student records here, all right? So when you're trying to call that function here, it's actually showing that all of this record here. So question is, does it remain in the scope? Right? So when you call add next grade, does it remain in the scope? No, it's not. But you are now increasing that. But by the time that this now is being executed, is this student records is a huge collections of that. We are somehow is holding that reference there, right? The thing is that student records, that's a proof of debugging wise anyway, the engine does not maintain the student record. We can also here is try to add some question. Is this possible here? Can I do this? Open a file, no, run a command, show console, show elements, lighthouse. How can I inspect that? The debugging here? That's a good question. Close. Let me debug here. So debug code. I do want to debug this code, right? Oh, can I add that debugger here? Okay, on the add grade, putting a debugger here. Debugger here. When you now call add, it's calling the debugger, all right, and it say now, this is how you can debug. Oh my god, getting into a new realm here. Fuck off. It say, hey, the new grade is this, all right, and when you inspect now what is the variables that we have in this scope, it say local and the closure. Okay, it's a manage student grades, which is the function. Now is closing over these two variables here, the grades and the source string, right? That's something lovely. Oh, it is under the scope here. So as you can see, the reference of the student record, right, is not holding it, right? So there is no reference of the holding, which is great, all right? But in order to make sure that actually work properly, okay, here, indeed, try debugging this code in a recent JavaScript engine here, like V8 in Chrome, placing a breakpoint. So the student record variables, you may notice that inspector does not list the student record variable, and that's a proof of debugging wise anyway. The engine does not maintain student record via closure, which is good. It only maintains the reference directly. It's only maintaining the lexical reference of the of that variable from the outer scope, not it is reference of other variables that it can have. But if you change now, for example, is the runtime conditions, okay, and you find out that, hey, okay, now things are going to be quite wild here. Yeah, things are going to be quite wild here, quite wild. So for example here, so at the end of the day, okay, we can now help is the engines by using that, uh, or being explicit to, hey, once you execute these functions, please remove the memory for this identifier. And we're not removing student record from the closure scope that we cannot control. We're ensuring that even if a student records remain in the scope's closure, the variable is no longer referencing the potentially large data, that the array can be garbage collected. Again, in many cases, JavaScript might automatically optimize the programs to the same effect, but it's still a good habit to be careful and explicit to make sure that we don't keep any significant amount of device memory any longer than is necessary. And here we are. So an alternative perspective, right? Is just to understand that how this actually works. That closure instead describe the magic of keeping alive a function instance, and it is variables. And now, why closure, right? Why in the first place we have closures? Let's get into this. It's a beautiful day out there. It is a beautiful day. So why closures here? So now that we have a well-rounded sense of what a closure is and how it works, let's explore some way it can improve the code structure and organization of an example program. Imagine you have a button on a page then that when clicked should retrieve and send some data via an AJAX request without using closures. Here you have now when the user click, okay, you should retrieve the data and send some data via AJAX request. So you got the data and you have the API endpoints, right? So make requests. You have now the button you target that. You get the kind of button that it is, okay? And if there is a match, okay, you get the button and you get the kind of ID. So what you're doing is mapping. So what you're doing here is mapping. Okay, so I'm going to map is this button is now the proper button to get the data and send it. Okay, and then you're gonna make requests. Utility only receives an event object from click events. From there, it has to retrieve the data kind attribute from the target button elements. And we use the value to look up both the URL and API endpoints. The issue with this is that you will have to, this works, okay, but unfortunately inefficient and more confusing. that the event handler has to read the DOM attribute each time. That's one of it. So you have to read you will have to go and read that attribute, okay? And why couldn't an event handler remember this variable? But reading data is not that inefficient, more confusing than that. But now you wrap this here. You say, hey, I'm about to define a function, and it's inside of these functions I'm going to now held that data here. So with the setup button handlers approach, the data kind attribute is retrieved once and assigns to the record kind variable at initial setup. Record kind is then closed over by the inner make request click handle, and its value is used on each event firing to look up the URL and data that should be sent. Events is still passed to make requests, though in this case we're not using it anymore. So if you need to read a variable once, okay, so anytime, okay. So anytime that you run this, you will have to read the data, but the data will remain the same. So we won't be able to just only read the data once and hold that reference to that. And hold the reference to that to do so. So by placing record kind inside of the setup button handler, we limit the scope exposure of that variable first, okay? Similar to this. So we limit the scope exposure of the record kind, exactly, inside of the setup button handler. We limit the scope exposure of that variable to a more appropriate subset of programs. To a more appropriate subset of program. To a more appropriate set of the program. Storing it globally will have been worth for co-organizations and readability, of course. So closures let the inner make request function instance remember these variables and access whenever it is needed. But what you're doing with closure is that, hey, I do want to remember this thing, and then if I need to update that, all right, we can do so. So closure let the inner make request function instance remember this variable and access whenever is needed. Building on this pattern, we could have look up both the URL and the data once at setup. For example, like this. Setup button handler, building on this pattern, we could have a lookup of both URL and data once. Exactly. I do want to hold is this data here, and avoid to read that data, avoid the operation of reading the data, which is pretty straightforward, pretty fast, but it wants you to hold that. Okay, so now my request is close over request URL and request data, which is a little bit cleaner to understand and also slightly more performance. two similar techniques from the functional programming paradigms that rely on closures are partial applications and currying. Hey, I do want us to remember this preset data, okay? Oh my God, that's my bandit stuff. I do want to remember this kind of data here. Okay, and briefly with these techniques, we alter the shape of functions that require multiple inputs, so some inputs are provided up front and another inputs are provided later. The initial inputs are remembered via closure, but this is a way of how you can now is remember all of this data, right? Or remember if this, remember this reference, and if this reference is doing some computations, okay, we can use remember that computation, and if we need to update the computations, we can do so. This is why when I look at the React dev tool, the React team in there, when they come out with in 2011, when they want to leverage the 60 years, well, back then 50, but right now it's 60. So the 60 years of software development research. So they don't want to slow down on that. Yep, most likely that. So they want to leverage. They want to leverage that. They want to leverage is on the software in the past. So we want us to research. So we want to leverage, or I want to leverage as well. So we want to leverage is the the R&D of software development over the past of the past 50 years, 60 years. Holy moly! All right. Holy hell. Okay. So briefly, with these techniques, we alter the shape of the function that require multiple inputs, and some inputs are provided up front and other inputs are provided later. The initial inputs are remembered via closure. Once all input has been provided, the underlying action is performed by creating a function instance that encapsulates some information inside via closure. The function with stored information can later be used directly without needing to reprovide that input. Exactly. So you are holding is this information that this function needs later on. So you hold that and use that directly without needing to reprovide that input. This makes that part of the code cleaner and also offers the opportunity to label partially applied function with better semantic names. So in other words, you can now grab this function define handler here and the setup button here. So to adding partial application, we can further improve the preceding code. So because the shape of this function now changed here, and we want is to now hold a reference to that, okay? So by the time that we call these functions, we're going to provide now the needed data as it is, and improve, of course, the readability of the code. So the request URL and the request data inputs are provided ahead of time. resulting in the make request partially apply make request a partially apply application or partially apply function, because it will receive is okay. It will receive this function when it is invoked, and you already have this reference remembering. So make request is a partially apply function here. So when the event eventually fires, the final input events, even though it is ignored, it is passed to handler, completing its input and triggering the underlying AJAX request. Behavior-wise, this program is pretty similar to the previous one, of course, with the same type of closure, but just by isolating is the function. But just by isolating is the make request function here in a separate utility defined handler, we make the definition more reusable across the program. We also explicitly limit the closure scope to only 2 variables needed. Closure to closure. As we close down a dense chapter, take some time, take some deep breath, and let it sink in. Seriously, that's a lot of information for anyone to consume. We explore 2 models for mentally tackling closures, observational and implementational, and summarizing the benefit of our programs. Closures can improve efficiency by allowing a function instance to remember previous determined information instead of having to compute it each time. And closures can improve code readability, bounding scope exposure by encapsulating variables inside function instances. Closures can improve code readability, bounding scope exposures by encapsulating variables inside of functions instance, while still making sure that information in those variables is accessible for future use. The result narrower, more specialized function instances are cleaner to interact with, since the preserved information doesn't need to be passed in every invocation. Before you move on, take some time to restate this summary in your own words, explaining what closure and why it is helpful for in your programs. The main book text concludes with final chapter that builds on top of the closure with the model pattern. That'll be all for this video. Take care. Bye bye.